Hi, we have a problem here on number 53, section 6.7. It's about compound interest, and it's talking about the average cost of a college tuition. There's two parts to the question, and this is actually an application problem. It's very wordy in the problem, so I kind of read it myself, and then I took the kind of important information and put it on the board so what we can use. So when you're doing this problem, you might want to read the problem yourself a couple of times and then look at this again after you see it the first time, and it would probably make a little bit more sense if you read the problem beforehand. But anyway, this is about a college tuition, and it says in the problem that the tuition was in 2005 $29,026 on the average. And it also said that the interest rate was 5.5% rate of increase every year. And they want to know what the cost is in the year 2015, which is 10 years. Now, it says in the problem it's 5.5% per year. That's basically stating that it's not being compounded but once a year. So it kind of looks like simple interest, but we can still use the same formula that we have been using. And like I keep saying in class, this is the big formula, and because it does not use the word continuous in it part A. Part B it will, but part A does not use the word, so it's the big formula. They use the word continuous, it's the little formula, which we'll talk about that in a second. So it's just a matter of just putting the numbers into the formula where they go. The principal, the present value is $29,026. The rate is 5.5%, so it's 0.055. It's only for uh, one year, because it's once a year. And then plug one in there, and then T, like I said, it's 10 years. It's over a 10-year period from 2005 to 2015. It's 10 years. Now, again, the N is 1 because it says in the problem 5.5% per year. It didn't say it's compounded monthly. If it said it was compounded monthly, then you'd be putting a 12 here and here. But this is compounded basically once a year. And then you'd have to pull out the calculator. And I have my trusty calculator right here. And so if I get $29,026 times 1.055 and raise that to the power of 10, it will be approximately, I'll round to the nearest dollar, it's 49,000 and $581. The calculator says $580.60. So I round to the nearest dollar. And so that's what it would be if you raise it at an increase per year of 5.5%. So 10 years from now, as you can tell, it's grown quite a bit. Now, on the other problem, it says, now what if it's growing continuously? And what do you have to invest now to get that amount of money? So you're going to have to do part A before you can do part B, because it says in the problem what is going to be the cost in 2015. Well, you have to write that from over in part A, $49,581. Now, the continuous compounded at 4%, so R is actually 0.04, and how much must be invested in the year 2005. So this is what you're going to need then. So what if you go back in time back to this 2005, and how much would you have to invest now? Well, you would have to use the little formula, A equals P times E raised to the RT, because the word continuous is used within this problem. And so you just start putting the numbers back into this one, but this time it's the ending amount that you want to be 49,581. So 49,581 equals the present value, which I believe is what you're looking for because of how much must be invested. And then the rate is 0.04. And again, 10 years, because it's 10 years from 2005 to 2015. So, and then you just have to solve for P. So P is equals to 49 0.581 over E, actually to the 0.4 power. Okay, so again, you'll need to pull out the calculator, and now this will be actually less than 49,581. Of course, it's 10 years ago, and so how much was it invested then? Now the question becomes, would it be more or less than $29,026? Because on one hand, it's got a lower rate, but it is continuous. So continuous, if all things being equal, is better than being compounded once a year. But this one's at a lower rate. So you might need a little bit more money here than you would be here because the interest rate is a lot lower. It's 4% compared to 5.5%, although this one's being compounded at a higher rate. It's been only once a year. So you got to play the good with the bad, in other words. But anyway, you just do the problem. So it's going to be 49,000. So we need to divide that by e to the 0.4. So I hit Shift LN 0.4. I think I have $33,235. So as you can tell, it's more than what you started with over here. So you're going to need more than you would have over in this case, simply because the rate is lower than over there. So being compounded continuously it doesn't help you enough. It doesn't help you much at all, because the rates is really the most important thing. So, but like I said, well, all things being equal, continuous is actually better than compounding once or 4 times or 6 times a year. So, but it's the rates, the telltale sign. So, but anyway, this is problem number 53, chapter 6.7. Okay, thanks.